My name is Matthew McKnight. I'm a technical specialist working out of the Melbourne office for Autodesk. I support the manufacturing portfolio of products, and today's webinar will be talking about what's new in Autodesk Inventor 2017, which many of you have hopefully got access to, maybe even have already installed. Now, the changes that have taken place inside of the 2017 release are focused around really three key areas, and those key areas in particular are around areas that will help you become more efficient and more streamlined in the typical workflows that you use. In highlighting these, I want to bring to your attention the three areas in particular that we'll be concentrating on today, and they are core design features. So they're the typical tools and workflows that you would use on a day-to-day basis to create the design assets or the designs that you're working on. A lot of these enhancements are focused on making the design process faster and optimizing the performance of that workflow. And I also want to highlight the fact that a lot of these changes actually come from the idea station. So these are coming from user requests and user enhancement requests, and often are voted on by the users. So it highlights the value of actually participating in that process. The second area is interoperability, and this is how we work with other companies, other entities to share data and share information between various different projects and teams. And then thirdly, the other area that I want to highlight is the communication and collaboration aspect of design today in today's changing landscape, because this is becoming a more significant part of the design and engineering workflow, and we'll try and highlight that as well through some of the changes that are taking place. So let's start off by looking at the design enhancements, and like I said, this is around a lot of the core day-to-day features and functionality that you use to create your designs and documentation. And there's been some significant changes in this area to enhance the workflows and make you become more efficient and the workflows to become faster and easier to do. The first area that I'd like to point out is the 3D sketch environment, and the 3D sketch environment is being overhauled to implement a number of changes that have come back from feedback from the community, again highlighting the value of using Idea Station. So this, in essence, is going to give you the ability to have greater control and enable you to develop faster the 3D sketch components of your designs. They've been completely revised, making it faster and easier to use, and a good example of this is the new 3D transform command, which gives you the ability to be able to manipulate geometry through moving and rotating quickly and precisely. There's now new constraint types that give you greater control and allow you to sketch curves on 3D faces as well. And there's also the ability to be able to copy and paste 3D sketches and then associate those sketches to geometry. So again, highlighting the value of some of these tools. But nowadays, with parts becoming more complex and more stylized, it's important to understand that surfacing and greater surface control can add significant benefit to your workflow. So in this case, what the changes around surfacing pay particular attention on your ability to be able to create advanced precision surfaces, but quickly and easily. And this is highlighted in the two areas that I've chosen to show here. Firstly, the ability to have greater control when creating when using the boundary patch command through the use of guide rails. And these guide rails can be in the form of points or curves or sketch elements, and that gives the ability to be able to create continuity and form within inside of your design. The other tool that I'd like to highlight is the ruled surface tool, which now has an angle option, enabling you to create a number of different surface types. Furthermore, the sweep option has also been renamed to Vector, and it now supports both edge and sketch selections to set the direction. So again, another critical functional aspect where there's a reliance on being able to create very precise organic geometry quickly and easily has been streamlined. From a part creation side of things, one of the areas that I like the best out of the 2017 release is the feature relationships, understanding feature relationships with inside of your design. So for instance, if you're a new employee with inside of a company, or you end up with a lot of legacy data from a previous CAD user, to understand how complex parts have been built and constructed can often be time consuming and difficult to do. So the feature relationships tool significantly improves that process, enabling you to quickly and easily understand all of the relationships, the parent-child relationships between part features within inside of your design. Furthermore to that, the circular pattern tool enables you to create patterns by fixing the orientation of the pattern feature. So in this case, where we've got a circular pattern of a feature, they may be a slot or maybe have to be aligned with a slot, giving movement in a certain direction, where you can actually lock the orientation of those features rather than having them rotate around the axis of revolution. And then multi-body support has also been improved as well, and that's further enhanced through the ability to be able to pattern and mirror features across multiple bodies. So in this case here, where we've got a cutout that's been put through a part, you'll see that cutout can then be patterned through both bodies in the one feature rather than having to be separate features. Assembly definition has been changed as well, and another area that I want to highlight, I see significant value in the component transparency tools. So you can now quickly toggle the transparency of a component inside of the assembly without having to apply a material or an appearance override. So you simply right-click the component and you'll see you've got a transparent option towards the bottom of the dialog box. You can use the Alt-T key as the shortcut key that gives you access to be able to quickly and easily switch transparency of individual components inside of your design. Furthermore to that, there's now a right-click context menu option that is available inside the assembly browser modeling view that lets you open reference files directly from your browser. And you'll also find there's enhanced reporting of cross-part references within assemblies, and this is going to help you more easily identify and access related parts. So all of this assembly definition tools, you'll see there's a common theme. It's about working with and understanding your assemblies much easier, being able to define and look at their relationships much faster. Sheet metal has always been a strong area of Inventor, but you will still see incremental changes like we're seeing in here. So no drastic changes to the sheet metal, but more incremental to continue the evolution of this area of the product. So new options let you control the individual punch representation display. You'll find that flat pattern overrides are added to the punch tool dialog box, and this includes show formed punch feature, show sketch representation, and show center mark. There are now options for round, tangent, round, vertex, and square vertex, which have been added to the corner reliefs. And the flat pattern compute option has been added to the modeling tab of the document settings dialog box, as has a defer update on flat pattern, which has been added to the file open options. So again, just nice little improvements into the workflow that we're seeing inside of the sheet metal environment. If you use the tube and pipe component of Inventor, that you'll now find that finding in-browser context menu option is now enabled during route creation, and this also is also available when placing flexible hose fittings. Likewise, when you're actually placing the flexible hose, you'll find that multiple intermediate point creation is available during that process rather than after the process. And for areas where you've got tight bend radiuses, You'll also note that there's now visual feedback for violations. So not only is it warning you that there's an issue with the bend radius of your hoses, you'll actually get a visual feedback on where those issues are. And a little bit further down, if we look at the user interface, there's been some changes in this respect as well. For those of you who have got a 4K monitor, you'll love the fact that 2017 now supports 4K monitors for high resolution icons, dialog boxes and geometry directly inside of Inventor. So almost to the point where you can capture your rendered images without actually having to create any renderings. You can just use the geometry themselves. You'll find that there is now several new shortcuts that have been added that will help you speed up common tasks. This includes the ability to be able to configure shortcuts for the likes of visibility and transparency and routed system commands, and this is in combination with all of the prior commands that you had access to. And you'll also find that there's improved graphics scene adjustments, and these have been made in areas such as luminance and brightness as well. So again, more subtle changes that have taken place. And just, capping off this area, I want to highlight to you Shape Generator and the changes that have been made here. And I'll follow this up with some videos or the video that will highlight this workflow, because Shape Generator was actually added in the 2016 R2 release. And it's a technology that gives you the ability to be able to look at conceptual design of components and make them as structurally efficient as possible. The workflow of using this tool has been improved through a number of key areas. So firstly, visual constraint feedback. So when you're adding constraints such as fixed, pin and frictionless constraints, you've now got visual feedback to show where they've been assigned. You've got interactive controls around the preserved region area, enabling you to quickly and easily be able to size or resize that to make sure that you're restricting interaction with areas that you don't want modified. You've got a minimum member size criteria that can be specified to make sure that the parts that you're making are manufacturable. And you can also now specify the target mass rather than having to calculate that based on a percentage reduction. And then finally, you can add symmetry control to make sure that the part is symmetrical about a plane as well. So let's have a quick look at this in action, and you'll find here what we're effectively able to do is use Shape Generator to very quickly and easily optimize the shape of our part. It might be to make use of less material. It might be to make use of the same material but in a more efficient way. It might be to actually improve the performance of the part. So there's a number of reasons why we might do this. So we see firstly that we now have the feedback of where our constraints are added. We can very quickly and easily manipulate our preserve region area, and we can add symmetry around a number of planes, giving us the ability to be able to make sure that our part is symmetrical about those planes. We can assign a target mass rather than a percentage reduction, and we can have a minimum section thickness, ensuring that the part is manufacturable, in this case ensuring that the minimum section thickness is 8 millimeters. Once this Shape Generator study is run, we can then use the mesh that's created from it, promote it to the design environment, and use that as a basis for creating the template that we can then remove material from our design. Now, in doing so, what we're doing is we're actually looking at better utilizing the part to carry that load. And from this, we can then run subsequent analysis, whether it's a stress or modal analysis, to look at our design and further understand its performance. So again, very impressive improvements in that area. And the one area in particular we've had a lot of interest from customers is around the Shape Generator technology. So moving into the next section of our What's New is talking about interoperability improvements. And this is really about how you share data. So whether it's sharing data in the form of information that you're wanting to give customers or clients, but potentially even the way that you work with people throughout your existing company, so such as interdepartmental, or maybe it's external to the company, such as through customers, through suppliers, through manufacturers. It could be a range of people that you're trying to collaborate with and share information. And that becomes critical nowadays because we're often working in multi-CAD environments. And this is highlighted with the release of the AnyCAD technology. Now, AnyCAD technology became available in the 2016 release of Inventor. And it gives you the ability to be able to work with non-native file formats and reference the data rather than convert this. Now, this is critical because rather than then having to convert the data into an Inventor format and manage that file and have a second file to manage, you're actually referencing the original file. So you can check that data into Vault and manage it the same way you would, say, an Inventor file. Secondly, any way that you use the geometry, whether it's using it through constraints that you're adding or references, or maybe you're running CAM toolpaths or you're running simulation, the setup time and the investment that you put in place into using that geometry isn't lost if you have to re-import it later on. All you're doing is re-referencing the data. So it's effectively a live link to the file. Now this works on a range of different third-party file formats, including CATIA, SolidWorks, NX, ProE, and Creo. But there's been a number of enhancements to the workflow in the 2017 release. So this includes increased support for multi-threading, meaning that there's improved performance, referencing the files. So the updates that take place are going to take place faster. Further to this, the step file format is now also referenced as well. So step being one of the most common, if not the most common, neutral file format, gives you the ability to be able to quickly and easily import or reference the geometry without converting it. So furthermore, and this is definitely linked to the previous topic of the AnyCAD technology, is the DWG Underlay Technology. In many ways, the DWG file can be treated in a same manner. So we can create that associative link to an AutoCAD DWG file, meaning that we can leverage it inside the design environment, inside of Inventor, and utilize that as part of our workflow. Now these links are associative, so changes to the AutoCAD file are replicated inside of Inventor on update. But the enhancements in this workflow include the ability to be able to crop details or unnecessary areas of the DWG file, meaning that you can remove that information from your design. It's also got improvements on the way that it associates placement of the geometry. So if you place or orient the component, then it remembers the orientation, movement, adjustments you've made. And you can also reinsert a DWG file. So let's have a quick look at this workflow and how it happens. So inside of Inventor, we can use or reference a step file and bring it into our design environment, remembering we're not converting the file, so we're not creating an additional file to reference and have to manage. In this case, we can then go and add constraints to the geometry. But the great thing is, if we go back in the original geometry creation environment, in this case Solid Edge, and make a change to it, if that file is then exported as the step file, you'll note that the design shows that the feature is out of date. We simply update it and the changes flow through into the environment. So all of our constraints are maintained. Likewise with properties that come from the original file, they will be imported into the geometry, but we can override those, noting that original geometry is shown as black, however the overwritten geometry is shown as blue. In the case where we want to leverage our legacy or AutoCAD files, then we can do that by using the DWG Underlay Technology. So we can use layers to hide any geometry that we don't want, but we can also crop any unnecessary information, improving the performance of this process. Placement of that sketch means that if we're moving and rotating the geometry into position, then that will be remembered. And we can then leverage that to then create features and functionality in our design. Also note that DWG Underlay can be shown inside the drawing environment. So in this case, we've actually used the underlay feature to be able to represent the geometry of a part that we're not going to model, but we still want to show it within inside of the drawing environment. We can do that, including listing it on the bill of materials. So again, further enhancements on tools that are going to significantly improve the interoperability that you have inside or using Inventor. Now, mesh handling is becoming a more critical part of the workflow to some companies, especially those that are taking on new manufacturing technologies like additive manufacturing, such as 3D printing. So with a file format in that a part of the industry is typically a step or an OBJ file, and that file format typically doesn't work all that well inside of the traditional CAD environment. So Autodesk has implemented a number of technologies and tools that help working with that data, or make working with that data much easier than ever before. So firstly, you can measure and section, use your measure and section tools on mesh faces. You can use the mesh geometry and select it and project it onto sketches to help you recreate geometry. You can use the fit mesh face, which will help you convert mesh face geometry to native Inventor surfaces. But you can also constrain and assemble the mesh geometry almost in the same manner that you can using Inventor native file formats, enabling you to create relationships between mesh and solid geometry. And you can also then, further from this, do interference detection. So let's have a quick look at that workflow. And here you can see maybe we've been sent an STL file, or maybe we've found it from an online library. We can import that into our modeling environment and leverage it in much the same way as what we would typically leverage any of our native file formats or any other imported geometry. So we can constrain it to our geometry. We can add instances of it, in this case patterning numerous. We can also check the kinematics of our design, so look for things like interference detection. If we wanted to replicate the part using Inventor's solid modeling tools, then we can reference geometry from the mesh data, enabling us to create sketches and then create features that can then be assigned to specific parameters of our or geometry of our component. And then furthermore from that, as we pointed out, you can use the fit mesh face command, enabling you to quickly and easily assign Inventor surface geometry to parts of the mesh data. So if you're trying to reverse engineer that design, this tool will significantly enhance the process associated with doing that. So again, looking at the future and next generational ways of using geometry and making sure that the capabilities are there to support that workflow. And finally, just finishing off this area of the interoperability, factory is becoming a bigger and bigger part, or factory workflow is becoming a bigger and bigger part of a lot of companies. So Inventor's ability to be able to interoperate with factory assets through parameters, which are essentially Inventor parameters, directly inside of AutoCAD. Furthermore, you've now got the ability to be able to sync the Inventor model with Navisworks. And also, if you're using Vault, like many of our customers are, this data can all be managed using Vault as well. So again, some nice improvements there to the factory design workflow. And then finally, finishing off, I just want to focus on the communication capabilities with inside of Inventor 2017, because communication is becoming a bigger and more critical part of the design process. And I almost mistakenly called it collaboration, and collaboration is often the key word that's used here, because more often than not, what we're finding nowadays is that, if we look back 10 or 20 years ago, engineers were typically they were downstream in the design process. They were often long after a decision has been made, long after all of the consultation with customers and clients had been made. They were the ones that were really just producing documentation and manufacture parts. Whereas now, designers and engineers are often front of house, often talking to customers, interdepartmental, suppliers, manufacturers, consultants, trying to get feedback on designs, improve their designs, help them become more innovative. And that's where the tools that have been implemented inside of Inventor 2017 help you leverage those new ways of working. So inside of Inventor, we now have what's called Inventor Connected Design, which leverages Autodesk A360. You will have seen the addition of Inventor Connected Design in one of the 2016 mid-cycle releases, but what you're finding is, again, incremental improvements into that workflow to make to highlight the value to you as a designer or engineer in using these tools as part of your workflow. So there's several enhancements, a few quick ones, so the ability to be able to collaborate and incorporate feedback, which can now be reviewed and managed directly with inside of Inventor rather than having to go to the A360 website to access it. And you've now got access to be able to control, permit, the sharing of part properties and part names in addition to the model graphics for more detailed reviews. So let's have a quick look again at this workflow. So a reasonably simple design that we want to incorporate on a platform that gives our suppliers or our customers quick and easy access to be able to review the design without the need for them to install any complex software, or for them to give them the ability to be able to access that anywhere. So you'll see that Connected Design runs directly inside of Inventor, and this gives you the ability to be able to share that design and collaborate with, and communicate with, the vested party. You can turn on whether you want to include component names or include part properties, and then directly invite someone based on their email address. They'll get notification of a design review request, and they can then directly access this model through the A360 web interface, meaning that all they need is a web-enabled device such as a computer, a tablet, or even their mobile phone. They can look through the properties, given the option to, and then provide information associated with the design. So in this case, they're providing feedback about the design. Back inside of Inventor, we now have the ability to be able to review that information without the need to go to A360, meaning that the path of resistance is much shorter and enabling you to really offer you the added benefit of a truly collaborative work interface directly inside of Inventor 2017. So some fantastic improvements to that workflow. Furthermore, the presentation environment has been enhanced to make your documentation creation tasks easier and faster. And this has been done in a number of ways. So firstly, you can easily arrange components in exploded views for drawing creation and quickly create powerful and expressive animations. You can create snapshots that allow you to capture specific model and camera arrangements, and this can be then used as part of drawing views or as raster image outputs. And there's also a new timeline-based story panel that makes it easy to control and edit assembly sequences or movements. So let's jump right in and have a quick look at this workflow as well. So here we are inside of Inventor, and we've now got the ability to be able to leverage these storyboards to create a sequence of events that captures the information that we're trying to portray. Often it's used in exploded views, but it might be used, say, for an animation to highlight a sequence of events, or potentially it could be used as part of sales and marketing material to be shown at a trade show to highlight how your component works or is more innovative than your competitors. So there's a number of ways that you can leverage this data. Notice, however, that the environment has been completely overhauled, giving you easier manipulation of the geometry, enabling you to quickly and easily create these and work with the presentation files. You'll note here that the storyboard can be easily modified, and you can create multiple storyboards to depict numerous assembly procedures. Here you can capture that as a video that shows the workflow, and you can add snapshots that will capture the orientation and the view settings of the model that can be used inside of drawings or for vector artwork as well. So if you're creating assembly or maintenance manuals, it could be used or leveraged in that way as well. So again, highlighting the value of improving the workflows, making you more efficient, and making those workflows more performance orientated for you. And finally, I just want to highlight one addition, and that is or a final addition, that is the 3D PDF publishing capabilities, which come with inside of Inventor 2017. So this gives you the ability to be able to export your models in the 3D PDF format, which can then be viewed inside of Adobe Acrobat Reader. So you get the ability to be able to select design view representations, model properties, and attachments to include. And then users of the 3D PDF can access this using Adobe Acrobat Reader. You can create a custom 3D PDF template that can be used to specify the arrangement of all of the exported elements within inside the output files as well, which gives you the ability to be able to completely customize this environment. So quickly looking at this workflow, again, it's simply a matter of defining your view representations that you want to use within inside of your assembly, and in this case, exporting the 3D PDF. Now, firstly, you'll notice this is powered by Anarch to give it the power and the complexity that has been enabled in this new addition and new tool. You'll find you're given the ability to be able to assign properties, design view representations, specify a template, attach documents to this file as well. So if you wanted drawings attached, you could do that, and then you can publish the document. So this sort of goes back to that collaborative community aspect and being able to share design information with people who are participating as part of the design process, and involve them much earlier, potentially much earlier in that design process, gathering feedback from them. This is highlighted in this case by bringing really the power of them being able to easily access and review the design using commonly used industry standard tools that give customers the ability to be able to interrogate the model and provide feedback, which is shown here through the addition of comments that can then be captured within inside of that PDF and then sent back to or distributed around the business. So again, another fantastic tool that's incorporated inside of Inventor 2017. Otherwise, I thank you for your time today. Hopefully you see the value of Autodesk 2017 in the various different aspects that have been highlighted in today's presentation. If you'd like some further information around the changes that have taken place, please consult the Autodesk Inventor page on autodesk.com. You can also gather further information from resellers in your area. If you go to autodesk.com/resellers, you'll find information about who you can talk to in your specific region. Otherwise, feel free to reach out to me. My details are there on the screen. Feel free to connect with me on LinkedIn and ask me any questions that you might have. Otherwise, I'll thank you for your time. I'll let you enjoy what is otherwise quite a beautiful day in Melbourne today, and hopefully we'll see you at one of our subsequent webinars in the next few weeks. Thanks for your time, and bye for now.